Hi scholars, welcome back to Primer's Classroom. So today we want to solve all of the possible questions on scalars and vectors. I expected you to have watched the video I posted the last time on scalars and vectors, where I have explained all the principles we are going to use in solving questions. If you're here to, please quickly watch the video, then come back to this class for solving all the past questions on scalars and vectors. And I can promise you, if you have gotten the principles right and you can solve all of these questions we're about to solve, you have no problem on scalars and vectors. I promise you that. So let's move on. So this is Jam Remix from the Jam Pass question. So we want to solve all of the questions. So I'm on page 2 now. The first question says that which of the following physical quantities is not a vector? So which of the following physical quantities is not a vector? A, velocity; B, work; C, force; D, electric field, magnetic induction. So in the last class I talked about scalar quantities are those quantities that show only magnitude, while vector quantity shows both magnitude and direction. And I gave various examples, and I also gave you assignment to look for more examples, and I gave you work as part of scalar quantities that day. So velocity, force, every time you hear field, electric field, gravitational field, magnetic field, all of them are vector. So they are vector quantities. So magnetic induction is the same thing as magnetic flux density, and in the class I told you that magnetic flux density is a vector quantity, but magnetic flux, it's a scalar quantity. So go back to the class. So the answer to this is option B, work. So the next question says that an example of a scalar quantity is A, velocity; B, weight; electric charge; and acceleration due to gravity, momentum. Velocity, weight, acceleration due to gravity, and momentum, they all signify magnitude and direction. So the answer here is electric charge. Electric charge is a scalar quantity. So if you don't know that before, you can add it to part of your examples. Weight, every time you see forces, they are majorly, except some components of forces. So when you see forces, they are majorly vector quantities. So let's move on to the third question. Which of the following is not a vector quantity? A, force; B, altitude; C, weight; D, displacement; E, acceleration. If you look at all of the examples I gave you that day, you will know that weight, acceleration, displacement, and force, they are vector quantities. Altitude is talking about height, and height does not need to give you any direction. So height is a scalar quantity, just like distance is a scalar quantity. So altitude is also what? A scalar quantity. So the next one we'll look at is 15. 15 says that which of the following quantities are scalars? Which of them are scalars? 1, electric potential; 2, torque; 3, momentum; 4, kinetic energy. So if you look at this, number 1, energy is a scalar quantity. Momentum and torque are vector quantities. So which means that any option that has momentum or torque, let's even say you don't even understand the rest, anyone that has momentum or torque is automatically out of our option. A is out because they are asking of scalars, not vectors. B, 1 and 2. 2 is there, so is out. C, 3 and 4, that is out because 3 is there. Then D, 1 and 4. So you see the electric potential. Electric potential is the work done in moving a unit charge from infinity to a point. We'll be talking about all of these things as we move on in the class. So 1 and 4, energy is equivalent to work. So energy and work are scalar quantities. So that is D that we're talking about. So the answer is D. Number 16, which of the following is a set of vectors? A, force; mass; momentum. The moment you see mass there, you already know that's wrong. They're asking for sets of vectors, but mass is a scalar quantity. B, acceleration, velocity, and moment. Acceleration, velocity, and moment, those are vectors, because moment is talking about the force and the perpendicular distance. So moment is a vector, acceleration is a vector, velocity is a vector. So but mass is a scalar quantity, and every other option has mass, weight, and density; mass, volume, and density. So the answer is option B, acceleration, velocity, and moment. 27, which of the following consists entirely of vector quantities? That means it is only made up of vector quantities: A, velocity, magnetic flux, and reaction. I told you something, that magnetic flux is what? A scalar quantity. But magnetic flux density or magnetic induction, which is B, it's a vector quantity. So we'll be looking at that later. B says that tension, magnetic flux, and mass. C says that displacement, impulse, and power. Then D says that work, pressure, and moment. So looking at this question, option, there is no, because there is mass in option B, so that is wrong. There is power in option C, that is also wrong. Power is a scalar quantity. There is work in option D, that is also wrong. So if you look at it, option A says velocity, magnetic flux, and reaction. Reaction is talking about force. Velocity is also a vector quantity. Maybe they wanted to write magnetic flux density. So because magnetic flux phi is actually a scalar quantity, but magnetic flux density is a vector quantity. So let's check that out. So the right answer to this would have been option A if it had been magnetic flux density. But in this case, there is no answer. But if you get to an exam more, it is better you choose option A, because option A seems more correct, except that there is a typo. So B, C, and D, they are automatically out due to mass, power, and work. Do you understand that? So please, when you're going for option, you can confirm magnetic flux and magnetic flux density, which is a vector, which is a scalar. So check it out. So the answer is option A, but it should have been magnetic flux density. So let's look at 29. The pair of physical quantities consisting of vectors only are vectors only. A, acceleration and speed. Speed, I told you, is a scalar quantity. Velocity is a vector quantity. B, displacement and torque. Both of them are vector quantity. Torque is just talking about the moment of a couple. You're going to know them as we move on. You know, one thing about learning is that it is gradual. When something seems confusing to you, as you move on in the class, everything becomes clearer. Oh, this is what you were talking about at a time ago. This is what you were saying. Do you understand that? So don't be too bothered. Maybe there are some concepts that seem unclear to you, but as you move on with the class, everything will become so clear to you. So let's move on. So the answer is displacement and torque. If you see option C says velocity and distance, distance is scalar, velocity is vector, but displacement is also vector. So this distance makes the answer to be wrong. D says that momentum and power. Power is a scalar quantity, momentum is a vector quantity. So the next question, which of the following is not a vector quantity? It's like the one we solved before. The answer is what? Altitude. 37. The pair of physical quantities that are scalar only. This one is asking for scalars only. A, volume and area. B, moment and momentum. C, length and displacement. D, impulse and time. Impulse is a vector quantity. Displacement is a vector quantity. Length, time are scalar. Momentum and moment are vector quantities. So the answer is A, volume and area. Volume does not need to specify direction. So volume, total quantity that occupies a particular space, and no. So we are talking about volume and area. They are scalar quantities. So that is the correct answer. 39. A quantity which requires magnitude and direction to be specified. So if they said this quantity requires both magnitude and direction to be specified, what do you think they are talking about? That's a vector quantity, because vector quantities signifies both magnitude and direction. So the answer to that is B, displacement. Number 40, Roman figure 1, electric potential. This was like the one we solved before, so let me skip this. You should know the answer to that question 40. So you can leave the answer in the comment section. Let me see what you have gotten for that question 40. So tell me what the answer is. So let's move on to page 17. So on page 17, I have sent all of these questions on the WhatsApp group for you to solve. So I'm doing the solutions now. So page 17 helps us to deal with all the calculation aspects. I gave you triangular. These are the list of the things I actually talked about then. So I talked about introduction to vectors, examples of vectors, representation of vectors, resultants and equilibrants, laws of vectors, triangular parallelogram law, and how to apply them, which I talked about the rules of vectors, the resolution of vectors into horizontal and vertical components. and we talked about all of these things to make it all clear. So now we want to now apply these things I taught you in the last class to solving these calculation questions. So the first one says that a man walks 1 kilometer due east. So you have to follow your cardinal points. You know, I told you the last time that we have the cardinal and the coordinates points. So now this one is saying 1 kilometer due east. So let's start the journey. You know, this is your north. So every time I go up, that is north. This is east, this is west, and this is south. This is your positive y, negative y, positive x, negative x. So if I'm going to the right, it is either east or positive x. So now this question says a man walks 1 kilometer due east. So that means I have to go to the right 1 kilometer. And then 1 kilometer due north. North is up. So the man keeps going, then he moves due north 1 kilometer again. So the question says that I should find his displacement. Remember, when they talk about displacement, what does that mean? Displacement is a vector quantity. So you have to find both the magnitude and what? And direction. So let's solve that. So now, if you look at what I have here, this vector is moving head to tail. I explained that in the last class. So it's moving head to tail. So if it's moving head to tail, to get the resultant, what do? We start from the starting point to the finish line. That gives us the resultant. Do you understand that? And that looks like a triangular already. And in triangular, I said that when the angle between the two vectors is 90 degrees, we use Pythagoras theorem. Abi, I explained that and I gave you in the rules the last time. So let's look for the resultant displacement. So that is going to be hypotenuse square equals opposite square plus adjacent square. And that is going to be 2. Then r square, r is going to be square root of 2 kilometer. So our answer is root 2 kilometer. So, and you know you are writing JAMB. If you're writing JAMB, you will not be given calculators. So sometimes you need to learn how to solve in standard, in short form, in solving without calculator and all of those things. I'll be teaching you that part later. So let's move on. So now you're asked to find the direction. So we have gotten our magnitude because it's a vector, so it's specified magnitude. This is how far. So if you had gone from here to here, this is how far it would have gone. But in what direction? So we want to know the direction in which it could have traveled. So let's call that theta. So now this is the east, don't forget. So now looking at what we have here, let's get theta. To get theta, I have my opposite, which is the angle facing the side facing this angle. Then I have my hypotenuse and I have my adjacent. So what relates hypotenuse, opposite and adjacent? That is tan. So I said we use our SOHCAHTOA in order to find the direction. So then I'm using tan theta is equal to opposite, which is 1, over adjacent, which is 1. So tan theta is equal to 1. So theta is equal to arctan 1. And that arctan 1 is going to give you 45 degrees. So don't forget. Now, what I've gotten here is 45 degrees. But I told you something that you can either represent it using this angle or using this angle. You know, the total is 90, so it will still be 45. So which means my final answer is going to be, so my final answer is going to be north 45 degree east, because it's northeast. So north 45 degree east. Then my magnitude is root 2 kilometer. So it is root 2 kilometer north 45 degrees east. That's my final answer. So if you look at that, so option A says that 1 kilometer north 15 degree, 1 kilometer north 30 degree, C root 2 kilometer north 45 degrees east, and that is my right answer. So the answer is C. Number 8. So let's look at this number 8. The next question. An aircraft traveled from Calabar to Kano. If you're in Nigeria, you know where Calabar is and you know where Kano is. So from the east to the north and up. So now it flew first to Ilorin, covering a distance of 300 kilometers. Kano, Calabar, and Ilorin, they are states. They are different locations in Nigeria. So there's Kwara State, which is for Ilorin, then Calabar and Kano. So now, if first to Ilorin, covering a distance of 300 kilometers, 30 degrees west of north, Now let's follow this. You know, I told you something about how you determine direction. If the angle is to the east, then we say north of east. That means that I can say this is 45 degree north of east, meaning that the angle is to the east. So if I say 30 degree west of north, that means the angle is, or north of west, that means the angle is to the west. I'll show you, don't worry. So let's go on. Let me just read the question through. 30 degree west of north, okay, west of north, that means the angle is to the north. And then flew 400 kilometers 60 degree east of north to Kano. What is the resultant displacement? Just like what I just finished solving, but the difference here is that you have to draw the way the movement is, the bearing. So let's see how it goes. Spider-Man. So now, first is an aircraft traveled from Calabar to Kano as follows. This was how the journey went. He flew first to Ilorin, covering a distance of 300 kilometers, 30 degree west of north. So let me start from here because I'm going up. So this is north, this is west, this is east, and this is south. So the angle is to the north because it says 30 degree west of north. So the angle is to the north. So you can draw your 30 degree to this side. That's 30 degree west of north. But the distance it covers, 300 kilometers. So let me make this 300 kilometers. Then it arrived at a point. Then what now happened? And then flew 400 kilometers, 60 degree east of north. So if at this point now, it changes direction. This is north, this is east, this is west, this is south. I hope you're following. So, but now it's traveling 60 degree east of north, right? 60 degree east of north to Kano. So meaning that the angle is now to north again, 60 degree east of north. Are you following that? So they now say we should find the resultant displacement. So if you see the arrow of its movement, how is it going? This one is head to tail, Abby. The arrow is up, so it's touching the tail of this one that is going this way. So that's head to tail. So anytime they now ask you to find resultant displacement, so this is what we have. So don't forget that 400 should be longer than 300 in terms of the magnitude. So, but let me draw that again. So this is 400 kilometer and this is 300 kilometers. So if you look at the arrows, it goes head to tail. So I now told you that anytime you are looking for direction, it goes from the starting point to the finish line. So this is their magnitude now. So how do we get the magnitude? No, I told you the angle facing this side is what would determine what you're going to use. So if from what we said, I can use cosine rule here, or let's see how to do it. The general formula you use every time is r squared is equal to a squared plus b squared minus 2ab cos r. That's if you are using the angle facing r, then that's it. But if you are using if you are using the angle facing r, that is what you are going to use. So this is the formula. But if you are using, if the two of them are moving tail to tail and you are using the angle between the two of them tail to tail, that's what we did with parallelogram law. But this is looking like triangle law. So if you're using the angle facing tail to tail, that they are moving tail to tail, then you're going to use plus here. So from what we have here, we can use our cosine rule because I want to use the angle facing this. What you have for triangle law too is still cosine rule. Let's say this was what we have from the previous question we just solved. You know, we had 90 degree and we had like this, and we said this was the resultant. But in that case now, this was 1, this was 1. In that case, I could have used this formula too. But the only problem here is that this cos 90 will be 0. And 0 multiplied by this, everything here will be 0. and at the end, when everything here is 0, what do you have is going to be reduced to this, and that's why we are using this formula for this case, Pythagoras theorem. If the angle facing R is 90 degrees, then this is what you're going to have. So we don't know what this angle is yet. Let's get it from our diagram. I hope you're following. So now, if this part is 30, this part, let me just say this is the line eventually. So if this part from the north is 30 degrees, then this part is going to be 60 degrees. You know, that's angle that are perpendicular. So now, if this place is 60 degree alternate angle, then this place is going to also be 60 degree. This place is going to be 30 degree. I hope you're following. If this place is 60, what do you think this angle will be? The one to the north. It's going to be 30 degree because the total angle here is 90 degree. So automatically, if you look at this angle facing our resultant R, the angle is actually what? 90 degree. Let me go over that again. The journey was like this, started from here, moving at 30 degree, inclined to the north. Then if this place is 30, this place will be 30, alternate angle. You can solve it. Let's say this is a closed triangle now. So if this place is 30, you know, this place will be 60, and this place will be 90. And the total angle in a triangle is going to be 180. So if this place is 90 plus 60, that's going to be 150, meaning that the rest of this angle is going to be 30 degrees. So that's why we just know that this angle and this angle are always equal. This angle and this angle are always equal. That's just an analysis. So that's how I got my 60. So this place is 60, this place is 60. So if this place is 60, since this angle is perpendicular, then this place will also be 30. So if you close this place, that is 90 degrees in total. So the angle facing R is 90 degrees, which means that we are still going to use our Pythagoras theorem. Do you understand that? So how do we get that magnitude now? Using our Pythagoras theorem. So this would have been 0 because cos 90 is 0. So that's going to be R squared equals 300 all squared plus 900 all squared. So 3 raised to power 2, I think that's 9. So this should give us 900. So without wasting time, what would this give us? So let's check. So that is going to be, that should be 9 then 40. So that should be 9,000. Let's check. This one should be 81. Then there's a way we do some of these things. So this should be 81,000. But let's check. So that's 300 squared. That's 90,000. You might not have calculator, so you have to learn how to do some of these things. 900 squared. That's 81,000. Sorry, 800, and because it's 1, then this will be 4 zeros. 1, 2, 3, 4. So that's 810,000. So if you add it to, oh, what was I doing? Sorry, it was not 900. This was 400. It was 400 kilometers. This is 300, right? So this is going to be 400 square. That's going to be 160,000. So now 160,000 plus 90,000, sounding like money, that's like 250,000. So if you find the square root of that, you get 500. The thing is simple. Let's say you don't have calculator. You could have just done this as square root of 25 times 10 raised to power 4, which is the same thing as square root of 25 times, just say, and let me say square root of 25 times square root of 10 raised to power 4. At the end of the day, square root of 25 is just, square root of 25 is 5. Then 10 raised to power 4, it's like saying 10 raised to power 4 square root 1 over 2. 2 here 1, 2 here 2. So that would be 5 times 10 raised to power 2, which is 500 kilometers. So if you don't have calculator, you can do it that way. So don't get stuck in exam. So your answer is going to be 500 kilometers. So our resultant is 500 kilometers. So if they ask us to find direction, we'll find it. But in the option, they didn't ask us to find direction. So the answer is option D. So don't forget how the journey started. You can watch it over again to see how I got it. You can just play it back to see how I got it. So next question, if a body is acted on by forces applied at P and Q as shown, their resultant is equal to, I think you should be able to solve this. We have 4 Newton, we have 6 Newton. Now this is what I'm saying about rule 4, parallelogram law. But you know, these ones now, if you check them out from the way they are drawn, they are moving tail to tail. So what we have been doing before, they have been moving head to tail. So these ones are moving tail to tail. So whenever they move head to tail, you draw a line between them to get their resultant. So let's see how we'll get that. So now you have the first force, which is 4 Newton. Then you have the second force, which is 6 Newton. So look at this. The tail of this for 6 Newton and the tail of 4 Newton are touching. So they leave a common origin. Although the angle between them is 90 degrees. I already said something that anytime they give you the angle between them and they are moving tail to tail, you can just use this formula straight. R square equals A square plus B square plus 2AB cos that angle. Shall you get? At the end, it's still going to be Pythagoras theorem because everything here is still going to be 0. Shall you get? But for now, let's move on. So now, when they move tail to tail, how do I get their resultant? It's no longer going to be from starting point to finish line. It's going to be just draw a diagonal between them. That's almost like our parallelogram law. So if you draw a diagonal between them, this side will be equal to this side. Do you agree on that? 4 Newton, and the arrow will be up. This side will be equal to this side, which is also 6 Newton. So at the end of the day, if you look at this arrow and this arrow, it has now turned to triangular. So if you look at it, this thing is looking like this now. This is like this, the resultant, which is this one. Then this is 6 Newton, and this 6 Newton should be longer than the 4 Newton. So we have the 6 Newton, then we have the 4 Newton, then we have the resultant between them. So if you look at this, these guys are perpendicular, so this is still 90 degrees. They are perpendicular to each other. So at the end of the day, that is now forming a triangular. So it's just like still saying the same thing but in a different way. So let's look at how we're going to solve this. You should know how to solve that, I guess. So help me to find my magnitude and the direction quickly. So what do you think that answer is? So you know how to do that when you have this type. It's just like what I did in number 1. But now let me do it for you. So now we have r squared equals 4 squared plus 6 squared. So my r is going to be 4 squared 16 plus 36 and all. So my r is going to be, so I have so 14 plus 36, so root answer is equal to 5 root 2. So this is square root of 50, which is 5 root 2. There's a way we solve for root 2 and all of those things, but let's just go on first. So now from what we have here, my answer is 5 root 2 kilometer. That's for magnitude. But now what is the direction? How will I determine direction? I know opposite, I know adjacent, so I can use my tan theta is equal to opposite 4 over adjacent 6. So 4 divided by 6, 4 divided by 6 is going to be 2 over 3. So that's 2 over 3. So my theta is going to be arctan 2 over 3 in normal form, 0.6667. So shifts tan answer is equal to 37. So theta is equal to 37 degrees. So now let's now be careful. This place is, that's why I'm solving it for you, so that I use it to explain something. So this place is 37 degree. So if that place is 37 degree, how do we represent it? The answers can be in two forms. I said it when I was teaching the class. Your magnitude can be 5 root 2 kilometer. Newton. I think the units of the rest are Newton, so it's going to be Newton. So now 5 root 2 Newton, but if I'm using this angle, then it will be 37 degree north of east, meaning that the angle belongs to east. But if I want to use the other side, then this total here is 90. So if I say 90 minus 37, that is like 53. So let me say this is 53 degree. So meaning that I can say this is or 5 root 2 Newton north 53 degree east. So these are the two ways in which your answers can be represented. So you have to be very, very careful. So now let's look at our answer. A, what did I get here? Oh, I think my answer was 33, not shift tan 0.6667. Oh, my answer is 34, sorry, not 37. So if my answer here is 34, then this place is going to be 34 and this place is going to be 56. That's the only thing. So this place will be 56. So my answer is 56. So if you go to the options, the option says that 5, where is it? The option says 2 root 2, another option says 2 root 2 Newton in a direction. You can't really see it clearly what is written there, but root 2. So I think my answer is option D, 2 root 13. 2 root 13. So how can it be 2 root 13? So let's confirm that. There are two options that are even saying the same thing. Option C is saying the same thing as option D. This is my correct answer. It should be 5 root 2 is 7.07. 2 root 13 is 7.2. So I think there's a mistake in the options compiled here. So but the answer is what? 5 root 2 north 56 degree east. The most important thing is understand that I got it, and that is the next thing. So let's move on. So number 14, which of the diagrams in figure 5 gives the correct resultants R of two vectors P and Q? So which of the diagrams give the correct resultant? Look at option A. Option A says that 1, B, 2, 3, and no. So there are 5 of them. So let's look at the Roman figure 1. You will see that vector P and Q, how are they moving? T to T. How did they draw the R? But if they are to draw the R, what should they do? They should draw it diagonally. So not to come inside. So the arrow of the R is wrong in that question. So 1 is wrong. Roman figure 2, you see R, P and Q, they are moving T to T. So you cannot draw from the head of Q to the head of P. That is also wrong. Roman figure 3, you can't draw from the head of P to the head of Q. That is also wrong. Roman figure 4, yes, when you have P and Q moving T to T, their resultant is drawn diagonally between them. That's simply parallelogram law. So that is correct. So number 16. A body of mass 5 kg initially at rest is acted upon by two mutually perpendicular forces 12 Newton and 5 Newton as shown in figure 3. If the particle moves in the direction QA, so the particles is moving in the direction QA. You can't see Q, but let's assume that from that origin, that is QA. That is QA. Calculate the magnitude of the acceleration. So we want to know the acceleration, and the acceleration has to go in the direction of the force. And if you look at what we have here, we have two perpendicular forces, 12 Newton and 5 Newton. So they said I should calculate the acceleration along that QA, which is OA in my diagram. So now going across OA, what is the force pulling it in that direction? You know, I told you something sometimes ago when I taught you the last class. I said if you pull a force like this and you pull another force like this, so you're acting on a box. By the time you pull it this way, this guy will go this way. That's what we said. So they now said, what is the acceleration at which it is going that way? From Newton's second law, F is equal to ma. But what is that F? It is a resultant force. So now you are given a force 12 Newton and another force 5 Newton. And this force 5 Newton, they are pulling a load in this direction, which is the diagonal you draw between them. They now say, what is the acceleration? So that means you need to know the resultant force from what we have been doing. Then when you know the resultant force, you already know the mass of the body, then you calculate the acceleration. So let's do that quickly. Let me change my marker. So the question is clear. So 12 Newton force is like this. The 5 Newton force is like this. And at the end of the day, there is a direction O, let me call it Q now. QA, from Q to A. Don't forget that this side will be the same as this side, 12 Newton. And this side will be the same as this side, 5 Newton. So if you're asked to calculate the acceleration along this direction, then that means you need to know the resultant force, which is F sub r. So now, using our Pythagoras theorem, the angle that is facing that resultant is 90 degrees. So we can say F sub r squared is equal to 12 squared plus 5 squared. And that is going to be 144 plus 25. But let me use my calculator. It's with me. So 12 squared is equal to 144, 5 squared is equal to 25 plus 144 square roots of your square root of 169 is 13. So that means that F sub r is going to be 13 Newton. So the resultant force is 13 Newton. Note something, whenever you have forces of 12 and 5, their resultant is usually 13. You need to note that. It's not everything that you have to waste time in the exam on. If this place is 13 and this place is 5, just know this place will be 12. There are common sites like that. If this place is 12 and this place is 13, know this place will be fine. But let's move on. You should always solve for verification. So now that I know my resultant force, which is equal to my mass times acceleration, resultant force is 13. What was the mass given again? So the mass was 5 kilograms. So multiply by acceleration. So divide both sides by 5. So acceleration is going to be 13 divided by 5. So that's going to be 13 divided by 5. That's 2.6. So that's 2.6 meters per second. That is the acceleration. Is that clear? So that's it. Now, the next question. Do you understand this? Anyone you don't understand, leave a comment in the section. I will find a way to explain them better. So the next question, a block of mass 2 kilograms resting on a smooth horizontal force is acted simultaneously by two forces, 10 Newton, 10 Newton. One is due north, one is due east. The magnitude of the acceleration of the force is just like what I just finished solving. So try that on your own and leave the answer in the comment section. Let me see if you are correct. That shows if you're correct, that shows you got the explanation right. I will tell you some things later. Physics is all about principles. So let's look at number 23. So I had an issue with my audio, like I never knew the mic was off at this level. So I will be doing a voice overlay, just try and follow through please. So the question says that a man walks 8 kilometers north and then 5 kilometers in a direction 60 degrees east of north. Find the distance from its starting point. So now I'm about to draw the direction of movement. So the man works 8 kilometer north, so you can see that. Then 5 kilometer in a direction 60 degree east of north. 60 degree east of north. So I've drawn east, that is north, then showing you the north, east and west. So the man moved up the north. So now 60 degree east of north, how are we going to do that? It's going to be inclined to the north. Can you see? So 60 degree is to the north. That's what 60 degree east of north means. So he moved 5 kilometer 60 degree east of north. So that's east. Then the angle is to the north, 60 degree. So trying to draw it out again for you to see. So the magnitude is 5 kilometer 60 degree east of north, then 8 kilometer to the north. So you can see that they are now moving head to tail. Then I told you that when they move head to tail, you draw from the starting point to the finish line. And that's what I'm doing there. So we want to determine the resultant now. So if that place is 60 degree, you know, the angle is 90 degree in total. So that will be 30 degree. Then the angle below is 90 degree. You know, from that 8 to that E, that's 90 degree. Then the other one is 30. So the total angle in that triangle is 120 degree. And that is the one facing the arrow. So at the end of the day, we are going to determine the resultant using our cosine formula that I gave you. That anytime that you are using the angle facing R, how do you determine the resultant? So I never knew my mic was off all through this process, and it will be very difficult to go and record everything again. It's more stressful because I have a whole lot of work to also do. But let's just manage it together. So just follow through. So that's the diagram, that's the representation. 8 kilometer north, 5 kilometer 60 degree east of north. So now let's determine the resultant. So we're going to use cosine formula, which is but look at something. They said we should calculate distance. If you ask to calculate distance, distance is not a vector quantity, it is a scalar quantity. And if you are calculating distance, you don't even need to bother yourself about the angles or trying to find magnitude, but just add the values together irrespective of how you move. If you like, go up and down, just add everything together. That's distance, because scalar quantity only shows magnitude, they don't need your direction. So if they say 8 kilometer north, 5 kilometer 60 degree east of north, then you're going to just add it together. Then for the second one, so the second arrow I did there is that if they now ask you to find displacement, that's what you would have done. So you do r square equals 5 square plus 8 square minus 2 shall get. So that's what I'm just showing you. But yeah, they said we should find distance, and that's the answer to distance, 13 kilometer. But if they said displacement, then you use your cosine formula, and that's what I've written there. So that settles that. So let's move on to the next question. So in this question now, you are told that a lorry travels 10 kilometer northwards, 4 kilometer eastward. That's what I've represented. 10 kilometer northward, 4 kilometer eastward, and 6 kilometer southward. So southward will be that you move down. Then 4 kilometer westward. So it's going to move to the left now, 4 kilometer westward, and it's arrived at a point C. So you can see that's the diagram. So the lorry first traveled 10 kilometer northward, 4 kilometer eastward, 6 kilometer southward, and 4 kilometer westward. So then you are asked to look for the total displacement. So try and look at something here. The 4 kilometer and the other 4 kilometer, they are moving in opposite direction. And when vectors move in opposite direction, what do? You subtract, right? So when you subtract, that means that will be 0. For the 10 kilometer and 6 kilometer, they also move in opposite direction. So that's for the vertical. So when you subtract that, you get 4 kilometer. So explaining this, what you are looking for is just displacement. And displacement requires that the shortest distance between 2 points, that is displacement. Distance is, imagine they ask you to calculate distance here, just like what we just did. If it is distance, you will just add everything together. You don't even need to bother yourself about direction. That means you will add 10 plus 4 plus 6 plus 4. That will give you the total distance. But if they said displacement, displacement is the shortest distance between 2 points. And displacement is a vector quantity. So you know where it stops at t. That's the place. So you are only finding the distance from that point to T, from where it started to T. That's the same thing we have been doing. So the answer is 4 kilometers, but let's see how we do it. So I did an analysis to explain what I'm saying right now. So if they ask you to find displacement and distance, what is the difference? The state displacement, that line I'm drawing, that is just your displacement, because that's where it started and that's where it stopped. So that's displacement. So now, from what we have from the diagram, let's look at it. I want to give you an analysis now. So if it is distance, what would it have been? Then you will add everything together, all the values. Distance does not consider direction, it's a scalar quantity. We add everything together. So 10 plus 4 plus 6 plus 4, that will give you the total distance, just like we did in the previous questions. But in the displacement is just the shortest distance between 2 points. So this is an analysis. Let's imagine you left your home, you are going to school. Now you go towards the right, towards the east, covering 2 kilometers. Then you go back from the school to probably your friend's home. But going back to your friend's home, you only covered 1 kilometer. You can see in opposite direction. 1 kilometer in opposite direction. At the end of the day, what will you notice? That means if I say what is your distance will just be 3 kilometers, because the total distance, it does not consider direction. But for displacement is the distance between 2 points. So meaning that the shortest distance between 2 points, where you start and where you ended the journey, that's your displacement. That means from home now to your friend's home, that is your displacement. Just from home to your friend's home. Or just say that the 2 kilometers is to the right, which is positive. The 1 kilometer is to the left, which is negative. So you can now say plus 2 minus 1. Do you get that? That will give you 1. So that means that your displacement is going to be 1 kilometer. So plus 2, since you are going to the right, then you are now going to the left, minus 1. So that's 1 kilometer. So at the end of the day, your final answer will be 1 kilometer. That's what displacement is trying to calculate. But distance is you will add everything. So there's a difference between distance and displacement. I'm still going to talk about it on motion. So just try your best to understand what I'm saying at this point in time. So what will now be the displacement for this question from the starting point to the finish line? So if you see, it started from that 10 knots, then 4 kilometer right, 4 minus 4 there now. 4 kilometer to the right would be like, it moved 4 kilometer to the right, 4 kilometer to the left. So that's 4 minus 4, that's 0, Abby. Now, it now moves 10 kilometer up, 6 kilometer down. So if you say 10 kilometer up is positive y, so that would be 10 minus 6. Do you get that? And that will be 4 kilometer. So that means that the displacement is 4 kilometer knots. Do you get that? So it is more of 4 kilometer knots, but the total distance is 10 plus 4 plus 6 plus 4 without considering direction. So that's how we do it. So let's move on to the next question. Two forces whose resultant is 100 Newton are at right angles to each other. If one of them makes an angle of 30 degrees with the resultant, determine its magnitude. So here now we want to determine the magnitude for the two force, for a force that is inclined at 30 degrees to the resultant. So now, looking at that, we have done that before. So I've explained that before. When you have resultants, here now we have resultants and we have angles. So that means we're talking about resolution of forces. So they said we should determine one of the forces. The one we have been doing since morning, they will give you the components of the forces. They will give you the forces, then they will ask you to find the resultants and the direction. But here now they give us resultants and they give us the direction. So we are now asked to find one of the forces that is inclined to the resultants. So let's draw the diagram and let's see. So now if you draw the diagram, you already have your resultants. So starting from the origin, you remember we used to do it. If they move head to tail, then resultant will be from the starting point, Abby. So let's say that's vector A and vector B moving head to tail. Then the resultant is from the starting point, that's R, to the finish line, which is what they gave us as 100 Newton. Then that 100 Newton is 30 degrees. So it can be any one of the two. It can be, let's say B is making an angle of 30 degrees with A, or with resultant, or A is making an angle of 30 degrees with resultant. Either way, we want to determine that one that is making an angle of 30 degrees with the resultant. So which means that if I'm using A now, then I can find A. If I'm using B, then I can find B. Sure you get, it will still give me the same answer. So now I know A, I want to find A, I know R. So I will use SOHCAHTOA to determine. So I want to relate A and 100. So what relates adjacent? You know, that B part will be opposite. So what relates adjacent and hypotenuse? That is CA. So that is cos 30 degrees, or cos theta is going to be adjacent over hypotenuse. So the angle is 30 degrees. My adjacent is A. That's what I'm looking for. Hypotenuse is 100. So my A is going to be 100 cos the angle 30 degrees. And cos 30 is root 3 over 2. So that will be 100 times root 3 over 2. So 2 here 1, 2 here 50. So that's 50 root 3. So if you punch your calculator, 50 root 3 is 86.6 Newton. So the final answer there is option D. So the next question here says that the magnitude of the resultant of two mutually perpendicular forces F1 and F2 is 13 Newton. If the magnitude of F1 is 5 Newton, what is the magnitude of F2? So two mutually perpendicular forces means they are at an angle of 90 degrees to each other. So now let's say those are the two forces at 90 degrees to each other, and they are moving head to tail, so their resultant will be from starting to the finish line. So the resultant is 13 Newton, and that's what we have been given. So now we're asked to find F2. So let's say F1 is 5 Newton. Now note something, whenever the two sides are 13 and 5, the last side will always be 12 Newton. So we are looking for that F2. So if the two sides 13 and 5, you should know that that last side will be 12 Newton. If you have 12 and 5, the last side will be 13 Newton. If you have 13 and 12, the last side will be 5 Newton. So just note that it's not everything that you have to do in the exam or two. If you have practiced enough, you would have gotten used to it. So that's the angle made with the resultant, and that's 90 degrees, showing that they are mutually perpendicular. So now let's solve it using Pythagoras theorem. So hypotenuse squared equals opposite square, which is F2 squared, plus adjacent squared, that's 5 squared. So 13 squared is 169. So if you punch 13 squared, that's 169. Then 5 squared is 25. So take it to the other side, that's minus 25 equals F2 squared. So 169 minus 25 is 144. So then square root of 144 is 12. So the answer is 12 Newton on the other side. So do you understand that? So when you see questions like this, you can just pick your answers when you see them, or don't waste much time on them. So let's move on to the next question. So in this aspect, now you're told that a body of weight W Newton rests on a smooth inclined plane at an angle of 30 theta degree to the horizontal. What is the resolved part of the weight in Newton along the plane? Although a question like this is not really a vector question, we are going to do it when we get to Newton's laws, when we get to the what's it called, Newton's laws of motion, application of Newton's second law on an inclined plane. So we'll talk about it, but for now I will just explain it for the sake of just the class. But this is actually not a question that we have to be bothered here, but just for you to know. So they said the body is resting on the plane and the weight of the body acts downward. So when you raise the body up, it is inclined at theta degree to the horizontal. So you incline the body, then you realize that it is resting at theta degree to the horizontal. So now there will be a weight of that body that will be acting, that's theta degree to the horizontal. So the weight always acts downward. Then you have to calculate the components of the weight. I think this is when I discovered that my mic was not working. So then let's start going on without using voiceover again. Part of the weight in Newton along the plane. Actually, this is not supposed to be under scalars and vectors, but let me just quickly solve it. So the resolved part, because the weight will act downward, then there's a resolved part that will be vertical to the normal. I'm going to talk about this again, so I won't even say much. This resolved part is usually W cos theta. while these parts along the plane is usually W sine theta. We will talk about that later. So the answer should be this, should be W sine theta. It's not your scalars and vector question, so I don't know why they mixed it up like that, but we'll talk about that later. So you might not really understand this. You will understand it under Newton's laws of motion. I'm going to explain it later. It's not a scalars and vector question. So let's move on. So the next thing, question 37, two forces of magnitude 7 Newton and 3 Newton act at right angles to each other. What does that mean? They are acting at 90 degrees to each other. The angle theta between the resultant and the 7 Newton force is given by. So they already told you what. So if two perpendicular forces, they act at right angle to each other. It's almost like what we have been doing. So they are at right angle to each other. So they now say that two forces of 7 Newton and 3 at right angle, so meaning that they are at 90 degrees. But they already told us something. We're going to have their resultants like this. They now say that the 7 Newton makes an angle theta. So there's an angle theta. So this is the 7 Newton. This is the resultant. So the angle theta between the resultant and the 7 Newton is given by. So we want to look for this theta. So which means that this place is going to be 3 Newton. So let's see what our option looks like so that we know what to solve. So now to look for theta, we're solving for both guys, opposite and adjacent. So it is still using tan. So we can say tan theta is equal to opposite over adjacent. So which means that can give me 3 over 7. So theta is going to be arctan 3 over 7, and that is my answer. So the options are cos theta equals 3 over 7, tan theta equals 3 over 7. So that is my right answer. The next question, in the diagram above, P, Q, and R are vectors. Which of the following options gives the correct relationship between the vectors? So P is equal to Q plus R, P is equal to Q minus R, C, P is equal to R minus. This is talking about addition of vectors. When vectors move in the same direction, what did we say? We add them together. When they move in opposite direction, we subtract. But when you're talking about this, look at it. The diagram says that P R. So don't be confused with that R now, that's the resultant. No. In this triangle now, if I ask you that which one do you think is the resultant? Very good. You just look at the arrows. Look at this Q and R. They are moving head to tail, Abby. So the P is the resultant for the two of them, because that's from starting point to finish line if they move head to tail. So now addition of vector is stating that this R and Q moving in the same direction can be added. So you can now say your P is equal to R plus Q in that manner. If I want to change it now, like if they tell you that R is this way, positive, if R changes direction, it will become minus. Do you get that? So if I change this arrow now, if I flip it, then R will become minus, meaning that let's say I turn this triangle to something like this. This is still my P, but now my R is this way and my Q is this way. So meaning that I can change this to P. Oh, sorry, my Q is still what it is. So P is equal to minus R plus Q. At the end of the day, my Q is going to be P plus R. Can you see that? So anytime you flip direction, you will also flip the sign. Anytime you flip direction of a vector, you flip the sign. So R and Q are facing the same direction. Add them together, then they will be equal to, just say R plus Q minus P, because P is not going in the same direction as R and Q, will be equal to 0. So at the end of the day, you can say R plus Q is equal to P. So that's how you solve problems on addition and subtraction of vectors. So next question, 47. A ball is moving at 18 meter per second in a direction inclined at 60 degrees to the horizontal. So in this case now, we have to find the horizontal component of its velocity. I taught you how we do resolution of vectors, Abi, to resolve vector into vertical, horizontal components. So let's draw the free body diagram and see how this question is. So you have a ball that is moving at 8 meter per second. That is the velocity. So a ball is moving at 8 meter per second in a direction inclined at 60 degrees to the horizontal. So this is the horizontal line. Then there is a ball that is moving at 18 meter per second. That's the velocity in a direction 60 degrees to the horizontal. So they now said we should find the horizontal component. So we are looking for what we used to call v sub x. You know, if I resolve this now, this will be my v sub y. So this is the angle she gets. So I'm just, and I told you anytime you are using the angle that is to the horizontal, what will be your v sub x? It's going to be cos. So we're going to use vx is equal to 18 cos 60, and that is going to be 9 meter per second. You can resolve that. We did that in the class when I was talking about it. How we got v sub x. So v sub y is going to be v sin theta, while v sub x is going to be v cos theta. We have talked about that. So if you don't know how I got this, you can just check the triangle or you visit the previous video where we talked about it. Our purpose here is just to solve questions. So 48, a body on the ground is acted upon by a force of 10 Newton at point P. That force is pulling it. Can you see? What is the force needed to stop the body from moving eastward? That's just like an equilibrant. For this body to move eastward now, that means we're trying to calculate the horizontal component. Do you get that? We want to know what will drag it towards the east. You know that 10 Newton will drag it in a direction that has a component in east and north. So now, if we're dragging the body this way now, so if I have the body P is being dragged by a 10 Newton force, then there's an angle 60 degrees to the horizontal. The question, and this is east, and there is a northern force which we don't care about now. So the question is saying that what will stop this P from going eastward? That means I need to know the force that is pulling it eastward. So the force pulling it eastward must have been the horizontal force. Sure you get. So now if I say that v sub x is going to be 10 cos 60, you know I got that right, and that is going to be 5 Newton. So the force pulling this thing eastward is 5 Newton east, and that's my resultant in the horizontal direction. That is what is pulling it eastward. So if I don't want it to now move eastward, what will I do? I need to apply another force in opposite direction. There's a box on the ground. A 5 Newton force is pulling it this way. But the question says that what is the force that will stop it from moving this way? So a force that will stop it will pull it back in opposite direction. And that is also going to be 5 Newton. But now in the opposite direction, westward. So if it is moving east this way. So my answer is 5 Newton westward. Do you understand the analysis? So what is pulling it towards east is this 5 Newton towards east. What will stop it? 5 Newton towards west. So that should be my answer. So that's 5 Newton in the direction of west. Number 53. The resultant of two forces acting on an object is maximum if the angle between them is what? I told you when they are parallel to each other, then the angle between them is 0 degree, and that is when they will be maximum. That is simply saying that when they are moving in the same direction, so they will be maximum. I said it in the last class. So the resultant is going to be maximum when the angle between them is 0 degree. Two forces each of 10 Newton acts on a body, one towards the north and the other towards the east. The magnitude of the direction of the resultant force is, you should be able to solve that. I solved it already. We've solved several examples that look like that. So solve that 54. Leave your answer in the comment section and let me know what you get. So the figure V1 and V2, which are of the following diagrams, correctly represent the vector W equals V1 minus V2. this is just like what we just finished solving, like addition of vectors that I just rubbed off here. So we have w equals v1 minus v2. What do you think? That means v1 is going to be w plus v2. So w and v2 should be moving in the same direction. Do you agree to that? Why v1 is going to be the resultant, or v2 and v1 were moving in the same direction, why w is the resultant, then you now flipped v2 because v2 is negative. So let's look at it. Let's look at A. For option A, v1 and w are moving in the same direction. So let's analyze them one after the other. So option A, I have this triangle. So this is v1, this is w, and this is v2. So if you look at the arrows, if I want to represent it now, w and v1, they are moving in the same direction. So I can say v2 is equal to w plus v1. So if you look at what I'm given, does it look like that? No, because this is saying w is equal to v2 minus v1, and it is not v1 that is negative, it is v2. So option A is wrong. Let's look at option B. Option B says w v1 and v2. So option B is saying that w and v2 now are moving in the same direction. So that's saying w plus v2 is equal to v1. So now that means that w is going to be v1 minus v2. This looks like this, but let's hold on, let's check the rest. So this looks like what we are given in the question that represents it. So let's check option C. Option C says that this is w, this is v2, and this is v1. I can see. So that's v1. So now if you look at this now, v2 and w are moving in the same direction. So this is like saying w plus v2 is equal to v1, and I can say w is equal to v1 minus v2. So that looks like option B already. What's going on here? So let's check. We are going to analyze it, don't worry. So the figure v1 and v2, which represents w equals v1 minus v2, we are going to analyze it. So let's look at the third one. The third one says that this is w, this is v2, and this is v1. So v1, in this case now, w is equal to v2 plus v1. I think that is correct. That's what we have. So now let's look at which one is our answer and what is really going on. So if you look at the first one, or let me do something like this. Let's say w is equal to v1 plus v2, meaning that, let's say this is my resultant, w, v1 moving in this direction, then v2 moving in this direction. So w is equal to v1 plus v2. Now, how do I make this one to be negative? I'll flip v2. So if I'm flipping v2, then I'm going to have w, then the arrow will now be v2, and this is going to be v1, because I've changed it to negative. So what I have here becomes this, w equals to v1 minus, just like saying plus minus v2, which is the same thing as v1 minus v2 w. So let's now see which one is wrong, which one is right, between B and C. So v2, that's v1 minus v2. So the answer is looking like both B and C, because if this is v1 plus v2, then when I flip it, then this will become negative, and I'll give me this. Same thing here. So let's see if there's no error in the question. 56. You said the answer is B, but I think there's an error in the question. Both B and C are actually correct. So it's either they change this to something else. So both B and C are correct if you analyze them. If I say that this is W, then V1, and this is V2. So if I'm giving you this now, this is saying that W is equal to V1 plus V2. So if I want to change it, I can change it to W V1 and V2. So this will become W equals V1 minus V2. So which is what I have here. Or better still. Yes, that's it. That's it. So something is off in the question. So both B and C are correct if you follow what I've analyzed. From here now, W plus, from this diagram, W plus V2 will be equal to V1. Because W and V2 are moving in the same direction, then V1 is opposite. So at the end of the day, you take V2 to the other side, you're going to get W equals V1 minus V2. So this diagram actually proves that, okay, this thing is correct. The other one too, same thing. V2 and V1 are moving in the same direction. Oh, I think I made a mistake. So here now, I made a mistake. V1, V2, W are all moving in the same direction. So this is supposed to be W plus V1 plus V2 equals 0. Since they are all moving in the same direction, so you will add everything together. Sure you get. So this is what we're going to have. So this can never give us this. This will rather give us minus W is equal to V1 plus V2. So the answer is B. So not this. So do you get that? So sometimes you can work like that. So, and the answer is B if you can verify now. I didn't really see the arrow well before. So all of these arrows are following the same direction. So when they follow the same direction, you're going to add everything together. Is that clear? So we won't cut it because all these errors are normal. So when you are reading and you are making some errors, you have to just look deeply into it. Why did I make this error? What is really happening? That's how you learn. So everything should not just be smooth. So if I just go on to post now and cut all the errors parts, then you feel like, oh, this person never made mistakes. No, it happens. Mistake is part of life. So just calm down, look at everything and learn properly. So 57, if the angle between two vectors P and Q is 0 degree, the vectors are said to be what? If the angle between them are 0 degree, that means they are parallel. They can never meet. So one is going this way, one is going this way. So they are parallel forces. So they can never meet. So the angle between them is going to be 0 degree. But they are going to be perpendicular if the angle between them is 90 degree. So that's perpendicular. And if they move in opposite direction, it will be like 180 on the same line. So one is going this way, one is going this way. So the angle can be 180 between them. So all of those things you need to note. So the answer here is 0 degrees. So that means that they are parallel to each other. And can they intersect? No, they can never intersect. 58. The diagram shows forces 4 Newton, 6 Newton, 10 Newton, and 8 Newton, which act at a point 0 in the directions indicated. The net horizontal force is, I told you how to resolve in horizontal and vertical. So this question says we should calculate the net horizontal force. So how do we do that? There is an error in this question too from what I'm saying, because we're not given angles. So it's one of the things about all these past questions. So look at what we have here. You have a force 4 Newton, everything acting at a point O. This is 6 Newton, and there's an angle very big, 10 Newton, then So another angle, which is 8 Newton. Now they said we should calculate the horizontal component of all of these forces. That is f sub x. And I already told you how to solve f sub x. Just complete this triangle, this coordinates. So that I can have the plus y plus x minus x. So if you look at what you have here, we can solve this guy to the horizontal, then this is on the horizontal, this is then you get it. So but now we need to know these angles, but the angles are not even in the questions. So how do we get to solve them? You can actually solve for the angles if you want to, because if this place is 10 Newton, this place is 8 Newton, I think we can solve for this angle. If this is and this, yeah, I think we can solve for the angle. Can we do that? Let's verify it. There's no crime in trying. So now, if this place is 10 Newton, which is this one, the angle here, so this line here is 10 Newton, this line here is 8 Newton, then we want to know this angle. So if I call this angle theta, this is opposite, this is hypotenuse, this is adjacent. So now I can say what relates adjacent and hypotenuse, that's cos. So I can say cos theta is equal to adjacent over hypotenuse. That's 10 divided by 8, and that's 1.25. So shifts. So I can now say theta is equal to cos 1.25. So that's going to give me shifts cos 1.25. So you can see now I will shift cos 1.25. That's going to be wrong. So that's math error. So there's something that is wrong with the question. I was just trying to say, okay, let's even find our way out. Let's get the angles ourselves. But now it's math error, because cos theta is equal to adjacent over hypotenuse, 10 divided by 8. But this one will give you math error. The angle will give you math error. Shift cos 1.25 is math error. So let me see what they used if they didn't provide it. 58. Can you see? Maybe they just assumed that this angle is not even assumption, they just didn't show it. They said this angle is 60 degrees, this angle is also 60 degrees. They didn't draw it like up to 120 because they make this one bigger and this one smaller in the diagram. So we could have just guessed that the total is 120 and this place 60, but just like what do you call this angle? So from what we have here, let's just assume that that place is 60 and the other side is 60. So let's get our horizontal components. So let's leave all the magic we were trying to do before. So this is what we were given. So this 60 degrees, this is 10 Newton, that's 8 Newton. So now in order to find f sub x, what did I say? Anything that falls to this side is positive for x. Anything that falls to this side, and whenever you are using the angle that is to the horizontal, you will use cos, Abi. So we can say f sub x is equal to, here now, that would be 8 cos 60 plus 10, everything is still on the positive, plus 6 cos 60. Then this one is on the negative axis, minus 4. So at the end of the day, that's going to be 8 cos 60 is going to be 4, plus 10, plus 3, minus 4. So my answer is going to be 13 Newton. So it's going to be 13 Newton along horizontal, which is option D. So let's move on to the next question. The figure above shows 4 forces, 3 Newton, 10 Newton, 3 roots, 3 Newton, and 6 Newton acting at this. The resultant of the 4 forces is, so we have to find the resultant of the 4 forces, which means that we have to solve them. We have to solve them in horizontal and vertical. Then I did that in the last class, so solve that and drop the answer in the comment section. So the resultant of 2 forces, 12 Newton and 5 Newton is 13 Newton. What is the angle? The angle is perpendicular 90 degrees. I already did something like that. If the resultant is 13 Newton and the sides are 12 and 5, then the angle must have been 90 degrees. And if you want to confirm that, you can just do it this way. So you can say the resultant is 13 Newton, one side of the force is 5 Newton, and one side is 12 Newton. So you want to look for the angle between them. So theta, so that's going to be r square equals which is r square equals a squared plus b squared minus 2ab cos that angle theta. So now this is going to be 13 squared equals 12 squared plus 5 squared minus 2 into 12 into 5 cos theta. So let's quickly look for that. So that's 144 plus 25. That should be 149, 169. So that's 169. So 13 squared. Yes, 13 squared is 169. Then 12 squared is also plus 5 squared is also 169. So that's going to be 169 minus 169 equals minus 2 times 12 times 5. That's 120 minus 120 cos theta. So everything, so eventually this is 0, this is 120 cos theta. So divide both sides by minus 120. So that's going to be 0. So cos theta is going to be equal to 0. So theta is going to be cos 0. So shift cos 0 is 90 degrees. So my answer is 90 degrees. So when they are perpendicular to each other, then when you have them like this, then the answer theta is 90 degrees. So that's what that part is saying. So the next question says that the component of vector x along the direction of vector y is 0 when a, x is at angle of 45 degrees to y, b, x and y are in opposite directions, x and y are parallel to each other, x is perpendicular to y. So let's see this. The component of vector x along the direction of vector y is 0. So let's say this is, let's just say this is vector y. However you want to take it, let's say this is vector x. They are saying that the component of this vector x, which is along the direction of vector y, so let's say the angle between them is theta. However you draw it, that's what you're going to have. So now, if the angle between them is theta, what do you think is the component along y? You know, the angle between them. So if, let's say I'm saying this is v sub x like we used to do, you know, this is going to be v cos theta. So this is like saying my v sub x now is representing y along the direction of y. So I can say y is equal to cos x cos theta. Let me prove it. So this is like opposite, this is hypotenuse, this is adjacent. So now they now say that I want to relate y and x. So I want to find x in the direction of y, and y is adjacent, x is hypotenuse. What relate them is cos. So I can say cos theta is equal to adjacent y over hypotenuse x. Do you get that? We're not talking about y-axis or x-axis here. They are just using y and x. So I can say that y is equal to x cos theta. So they now say the components of this, the component of vector x along y is 0. So which means x cos theta, that's the component, is equal to 0. So y is along that direction is 0. So I can say x cos theta is equal to 0, which means that cos theta is equal to whatever x is, which is going to be 0. So I can say theta is going to be arc cos 0, and arc cos 0 is 90 degrees. So the component of vector x along vector y is going to be 0 only when vector x and vector y are perpendicular to each other. That's the only time it will be 0, when both of them are perpendicular to each other. So that's that question. I think you should be able to solve the rest on your own. We only have 3 more questions. Solve them and leave your answers in the comment section. So practice all of these questions that we have solved and let's see how far you have gone. So if you still have a problem in any part, please let me know, then I'm going to solve more for you to understand. So I'll see you in the next class.